Okay, I'm going to do another example of programs from end of chapter 2. This one is problem number 21. Okay, and I've shared my whole screen here just so you can see on this one that here's the formula that we're getting. So this is Newton's law on force between two bodies with a mass of m1 and m2, and it uses this gravitational constant here, which is k, um, and k ends up being that number there because it's 10 to the negative eighth. And we can just do it in scientific notation later, but I wanted to note there as well. Okay. So you have to convert this formula on the left here into just one line. Okay. So what I've done here, I've started with the inner part, the M1 times M2, the two masses together. Okay. All of that divided by D. Okay. Is that D squared? That looks like D squared. That changes the world a bit. So my test case is probably wrong. So I saw the two and messed up. I'm going to go forward just like that's D and not D squared, just for this work through. And then we'll try to fix it at the end because my test case won't work otherwise. Okay. So yeah, you got to read these carefully. But anyway, the D's here, and then all of that is multiplied by the K. Okay. And I need a multiply there too. Because in math, you can just put things together and it's assumed that it's multiplication. Can't do that in C++, okay, or Python either for that matter. Okay, so now I'm going to stop this share and share just the program so it'll be a little bigger on your devices. Okay, so anyway, so yeah, that test case will not be correct, but I think we can figure it out. Okay, so as always, we're going to go through and put in our scaffolding. Again, I'm not putting in my name and date. You should, okay, and what the program is. Note that when you have a formula like this, it makes some sense to give some context. And I like this idea of putting a test case up here, okay? So I think that makes some sense. Okay, so first we have to declare our variables, okay? Then we have to ask the user for, if you read the problem, the things that we have to ask for are going to be the two masses and the distance between them. Okay. So say the mass for both objects, distance, say meters. And let's put the mass. I think if we can read it, it doesn't really matter that much. Looks like it's in grams. So the mass for both object in grams, and then the distance is in meters. Okay. We can then calculate the force. Okay. And then we can then display the results. Okay. So as far as our variables go, I'm going to start with this gravitational constant. And just so this makes some sense, that's in centimeters squared divided by grams squared. Okay, just so we have some idea what we're doing up here. Okay. So our K then is going to be equal to 6 point, okay, type here has to be a double. It's a very small number, is equal to 6.67. E gives us the engineering notation, that's what they call it, negative 0.8. It's 10 to the negative 8. Okay. If you preferred, you could just do it as you did up there with all the zeros. Has 7 zeros since we're moving it one decimal place first. Okay. So we're going to have that, and that's going to be a constant. That's a constant double K. Okay. And then the others should be doubles as well. Okay. So we're going to have a double for M1, we could call it M2, and D. All seems okay. Okay. And then, as always, when we're asking for the user, we can do this in three statements or in one. I'm going to go ahead and do three. Um, no, actually, yeah, let me do three. Okay, so say enter the mass in grams of the first object. It's a little more user friendly. Okay. Then do a CN on the M1. If you watch the other video I have out on problem 22, you may notice that I did not put it in the CS C1180 directory. So you want to do that. Okay, this one is in the correct directory. Okay, so I'm going to basically copy that and paste it at least one more time. The second one's going to look pretty much like this one. And that's second object. Okay, and that goes to M2. Okay, then I can come here and say C out, enter the distance. Between the objects in meters. And the D. Okay. So that should take care of that. And then I should be able to basically, if I've called things the same here, they're close. I've got the M1. You don't want to use capital letters for your variable names because that implies a constant. In this case, the K should be a constant, should be a capital, but the formula doesn't have it that way, so we won't worry about it. So, that means I'm being inconsistent. So that means I shouldn't be. So let's go ahead and keep it like the formula. I think that's worthwhile. We'll do that. We'll change that. We'll change that. Okay. So then down here, I can yank that formula back. Okay. And we have not defined F. That's something else we need up here. So again, I'll use a capital letter. I shouldn't normally do that, but we're going to keep with the formula. So F is equal to K, which we're defining up here as a constant. And then we have the M1, the M2, and the D. Okay. So let's see if this gets the correct results. And then we can see out gravitational force is okay. Let's see if we get correct answers here. And you need pretty big numbers or the force is pretty small. So I think I put 1 million, 2 million, and then let's see what that comes up with. Okay. First, we'll see if it compiles. So I've got a G++. Do I have all this in here? Maybe I did this once. Yeah. It compiles. Okay. Now let me run it. Okay. So I want 1 million. Can't enter it with the zeros. I want 2 million. And I want 2. Okay. And I get 66,700, which is what the test case should be. Okay. But we now realize that was incorrect. Okay. So that should be D squared. So let me make this correct. Let's say D squared. Or to keep it in the format, put an extra set of parentheses, D times D to make sure that happens first. Okay, then I can change this down here, same way, to D times D. We could also use the math POW, power function, do it this way instead. So now I don't know what I'm going to get. So, but if we compile it, just like something. Oh, I needed to add an extra parentheses. That's what it's telling me. I added 1, but not 2. Okay, so I add 1 more parentheses there. Okay, Control X, Control C, yes. Up arrow to get to the compiler. Seems okay. Up arrow to where I run it. Doesn't matter now. Back to the same one. Okay, this should be a smaller number, and it is. It's 33,350 is the force. Okay. Now, the next chapter, it'll talk about how we can format this a little bit more nicely. Okay. And you may want to say the gravitational force between an object of mass this and mass that. You could make that a lot, a lot more, a lot prettier than that. But that's the basic idea. Okay. Let's take a look at the code one more time, see what we're doing here. Again, here's the formula we're using. I had it wrong, but I fixed it. I need to recalculate my test case. That test case is now incorrect. The test case I just did on a calculator. Okay. And then I'm including IOStream using namespace standard and int main. I'm setting K to be a constant. It needs to be a double because it has a decimal portion. Okay. And then it's 6.67. The E is saying like times 10 to the, and then negative -0.08. Okay. And that should get me the correct numbers there. And then I've got the doubles for M1, M2, D, and F. Again, I'm using the capital letters, which I normally wouldn't, to match the formula. I'm then asking the user for the weight or the mass of the first one, mass of the second one. Okay. And then getting the distance between them, calculating the force, and then displaying the results. Okay. So hopefully these examples are useful for you. Okay. You should be able to do this kind of a program in pretty quick order. Okay. So if you have questions or if you want me to solve any of the other problems, make sure that you let me know.